This is lesson 4 in the sounds topic, and the title of this is Using Sound. This presentation will play automatically, so you don't need to press any buttons, but you can advance it by clicking if you wish to. You're going to see 4 images which show 4 different uses of sound, and then I'm going to ask you some questions on them. This is an ultrasound image of a baby growing inside its mother's uterus. So, in each case, what is producing the sound? In the first picture, it's the ship's sonar. In the second picture, the ultrasound probe. And the third picture, the bat is squeaking to produce ultrasound. And the fourth, the dolphin is making clicks to produce sound. In each case, what is the sound travelling through? What is the medium? The first one, it's water. The second one, it's the mother's body. The third one, it's air. The fourth one, water again. What is the sound being used for in each of the 4 cases? First of all, the ship is using sonar to calculate the depth of the sea in order to create a map of the seabed. In the second case, the sound is being used to create an image of the developing fetus. In the third picture, the bat is trying to locate its prey for food. And in the fourth case, the dolphin might be trying to locate prey or might be trying to be aware of predators. Also, the shark there is using hearing to detect its prey. 2 learning objectives for this lesson. The first one is to describe how ultrasound is used, and secondly, to look at how sonar and echolocation actually work. There are some key terms here. First of all, transmitted, which means to pass through something. You can use that for light or sound. Absorbed means taken into and it doesn't come out again. Reflected means to bounce off something, and an echo is a reflection of sound. First objective is to describe some uses of ultrasound. Animals use sounds in a variety of ways for different things, amongst them communication. A phone, also used for communication, that takes sound, converts it to electrical signals or radio waves, and then converts it back to sound at the other end. Try and think of 3 ways you've used sound today. You might have used it for talking, you might have used it for shouting a warning, whistling, humming, singing. There are a variety of ways you might have used it. We've already seen that sound waves transfer energy, and when this energy hits a material, there are 3 things that can happen to it. Either it is transmitted, it passes through it, or it is absorbed, it's taken into that material and basically heats it up, or it can be reflected. Different materials do different things to sound waves. So hard objects tend to reflect them, soft objects tend to absorb sound more. So ultrasound, as we've seen, is sound which has a frequency higher than human hearing. So that's above 20,000 Hertz. And ultrasound is widely used for treating soft tissue injuries. So here, a physiotherapist is using ultrasound to reduce scar tissue on a sprained wrist. It can also be used to form images of a baby inside a mother. You could use X-rays to produce an image of a baby inside its mother, but that does have some degree of risk to it. using ultrasound has no risks at all and is completely safe. Another use of ultrasound is for cleaning delicate objects, such as jewellery or surgical instruments. And these are simply put into a liquid cleaner, and ultrasound is applied, which makes lots of little bubbles which loosen the dirt when they burst. We're going to watch a short video which explains how this happens.
An ultrasonic cleaner consists of an ultrasonic tank filled with a cleaning agent, oscillating systems, and an ultrasound generator. When the ultrasound is activated, the generator supplies the oscillating systems with electrical energy. These transfer the oscillation to the cleaning fluid. The oscillation causes a rapid pressure tension change in the cleaning solution. The pressure tension change generates cavitation bubbles. These bubbles grow and implode. The implosion creates the cleaning effect. The object to be cleaned in the ultrasonic bath is therefore cleaned within a few seconds. Highly magnified, you can see how the cavitation bubbles grow and implode, and how the water pressure that is generated effectively dissolves and removes the contamination from the objects to be cleaned. Bandoline, high-performance ultrasonic cleaning, intensive and reliable.
To our second objective, which is to look at sonar and echolocation and explain how they work. So first of all, echolocation. An echo is a reflected sound, and bats and dolphins use echolocation to find food. They produce bursts of ultrasound and they listen for the echo. They can tell the direction from which these sounds come, and they can also tell how far away they are by the time the echo takes to return. Bats, as you probably know, use echolocation to find insects at night because there's not enough light to see them. And dolphins use echolocation to find food in water because sound travels through water much better than light does. Light is absorbed very quickly in water. You can see a moth called the dogbane tiger moth. And this is quite a unique moth because it produces ultrasounds itself, but it doesn't do it for echolocation. Can you think of a reason why it would do this? How does producing ultrasounds help it to survive? Well, if I tell you that this moth is actually prey for bats, you might get a clue, because what it does, it hears bats' ultrasounds and produces its own to confuse the signal, so that the bat doesn't know whether the signals it's listening to, the ultrasounds it's hearing, are from the moth or from itself, and that avoids the moth becoming the food for the bat. Sonar works in a very similar way to bats echolocating, and humans use sonar for three purposes really: for finding shoals of fish if it's a fishing vessel, for finding the depth of the ocean, and if this is shallow, it's important to stop the ship running aground, and in a military use to find submarines. The word sonar is actually an acronym, and it stands for Sound Navigation and Ranging. So how does sonar work? Well, the sonar machine produces a high frequency sound. The sound travels down to the object, the submarine, the seabed, the fish, and is reflected back to the ship. The sonar then measures the time taken for that sound to travel to the object and back, and from that it can calculate the distance that the sound has travelled. We'll do a little calculation here to show how this works. We know that sound travels at about 1500 meters per second in water, a lot faster than through air. Let's say then A ship is on the surface of the sea, it sends out a signal, and it takes 4 seconds for that signal to reach the seabed and then be reflected back to the ship. So we need to work out 2 things. How far has the sound travelled in those 4 seconds, and how deep the sea is under the ship. In 4 seconds, at 1500 meters per second, the sound will have travelled 6,000 meters, 4 times 1500. But that is not the depth of sea, because the sound has travelled down to the seabed and back up to the ship. So it's travelled twice the distance. So the actual depth of the sea is half of 6,000 meters, which is 3,000 meters. And that's pretty deep. This is a young man called Lucas Murray, who is blind, but he's learned to actually use echolocation himself. He makes a clicking noise with his tongue. You'll see him do this in a minute. And from that, he can tell information about the objects around him. He's able to do this because we usually use a very large part of our brain to process visual information from what we see. Now, he is not using that, so he's got spare brain capacity, which he can then turn to a different purpose to analyse echoes. Have a look and watch this little clip.
And then try the other one. Which one's the big ball? Good boy. See? Go for it. And then try the other thing. Which is the hard thing, Lucas?
Ooh, there's no like it. And then watch out. Okay.
Okay, that's it for this lesson, but as usual, there's a couple of more things I want you to do. There's the recap quiz, which asks some questions on the content of this lesson, and I'd like to do at least one worksheet. And there's a third thing you might like to have a look at. There's a clip here, which is just about 3 minutes, which explains why you should not swim close to submarines. Okay, I'll be speaking to you soon with lesson 5.